Yes. Do you hear me? Should we get started? Hello?
Yes.
Yes, teacher.
Right. Yes. We are going to get started. I am seeing the people outside. So we even have guys in the classroom. So I don't know whether I should address you as ladies or ladies and gentlemen, because I'm seeing it's a good number. Of male names and male students. Anyway, as for now,
Which subject is this?
Chemistry.
we are limiting the interactions between yourselves. You cannot view yourselves, you can't send a message. What does the timetable say? The timetable talks about chemistry. It will be
It's bad. I'm not saying anything. It's just the math. Baza kureba kugira ngo
in a suspended while, they speak as for now, let us try to use available resources. Some bit noted. All right. As for now, to mute all of you. But after some time, will allow us to interact. And I'm going to mute all of you for purpose of security, because there are people with heads and the box making noise behind. Right. I was saying, for the meantime, for purpose of lesson flow, I'm going to you, and I'll unmute you at a later stage.
coming at each and every time can just sit down and tell me what you're doing this meeting. It might seem insensible, realistic and just deal with it. I'm tired of you thinking that I want to be hardy. When did I ever say that? What did I ever do to show that?
Okay.
Because changes happen. I'm not the same person that used to run around or do stuff like that.
Those who are discussing, we are all listening to your conversations. Remove you from the chat. All right. Okay. What we are going to be looking at is bonding. Now that today I have a bigger population. We are quite many. I'll try to be slow. Try to reintroduce bonding slowly. For those of you who had gotten the aspects of bonding, it is more of a bit of now revision for you. So use this opportunity to grasp as much as you can, because after this I'll be relatively very speedy. So our interest lies in bonding. I'm expecting definition of bonding. If you can define what a bond is or define bonding, then you are with me. Number two, I expect all of us to know the different types of bonds that can be formed. Some of these bonds, the different types of bonds. You may come across certain types of bonds, but they may be a little bit of a higher level. So we shall cover what belongs or what is supposed to be covered by ourselves only. Number three, I expect us to be in position to describe and explain each type of bond, draw diagrams, and give the properties of each type. If that is over, then most likely we shall be in position. Atim, Amina, can you mute your microphone? You are giving us very bad feedback. Atim. Thank you. So we are saying definition, types of bonds, explain each type of bond, draw diagrams to illustrate and assess the properties of each type of bond. The people who have been on lessons previously have moved slightly ahead. Now that many of you have joined in, you have chosen to go back slightly and begin to move slowly. However, any form of indiscipline not to be tolerated, we shall remove you from the chat. Take note of that. So, when you are defining a bond, I'll begin with this aspect to come to this aspect. Then you continue. When you are defining a bond, before I give the definition of a bond, I want to liken this to a simple relationship, interactions that we have at home, with neighbors, at school, wherever we go. So what keeps you in your home? Because you are my son, you are my daughter, you are my brother, you are my sister. There is that relationship that binds you together. Feel for one another. In chemistry, we refer to that as a bond. A force that binds two or more people together. In chemistry, it is not people. In chemistry, these are elements. So that interaction between two or more elements, binding them together, holding them together is what we call a bond. And therefore, at home, maybe blood relationship, with neighbors, it could be friendship, it could be over a game. Football is the one that unites with another person. Maybe it is netball. Maybe it is watching, that kind of thing. So whatever is going to put two or more people together and links them is what we refer to as a bond. I never buy beyond 2 sumbis. So that is what you can afford to buy for a friend, is what you can donate. There is a limit. That's why at home they say, please make sure you don't spend beyond 2,000 shillings a day. That becomes your balance. Is the maximum money you can afford to spend. And if I'm to give you money at home, my son, my daughter, it means the maximum I can give you is 2,000. So if I want to give you 1,000, say, Daddy, 1,000 is not enough. For me, each day I spend 2,000. So if I have 1,000 in my pocket, then the mother also brings 1,000. I bring 1,000. Together it becomes 2,000 and we give you. That is it. If you want to give out 5,000 shillings, but for you want only 1,000 and you must give out the 5,000, what does it mean? You must be how many? 5. So that each one takes 1,000, the 5,000 shillings is gone. Combining power. Allow me to shift from this board to something. Right? Kalumba, your hands and the cocks are disturbing us. Mute your microphone. We are not studying agriculture. We are not chasing some to slaughter them, please. So I want to remove this part of the board. Hoping that we have captured something. All right. Leila Mutes, if I ask you to define a bond, can you define a bond? Respond quickly, and I'm on roll call now.
Yes, teacher.
Can you?
Yes, teacher, I can define.
All right. I am seeing Trophy's hand up.
Teacher?
Trophy? Yes?
Wanted to ask. So
Be louder.
Like now that the electrons under group 1, 2, and 3 can donate electrons, they are also allowed to donate to what? These non-metals of electrons under 4, 5, 6, and 7. They are
Definitely, yes.
Are the metals?
Are the metals
Yes?
what?
Are the metals allowed to donate to the non-metals?
Definitely, there are 2 people. In blood donation, you cannot donate blood to a person who doesn't want to receive it. We have said that metals donate, non-metals do what? Accept. So what does it mean? Donation is between metals to non-metals. You have answered yourself. Answer Muzanyira. Checho chenyini. Yes, Walda.
Teacher, the definition you gave for bonding, isn't it the same definition for a chemical bond?
That is it. You have answered yourself too. That is it. It is a chemical bond as a result of a chemical reaction. Yes, Elizabeth? You are free to ask. So don't just sit.
Teacher,
yes, please.
I was inquiring about group 4.
Group 4.
I thought group 4 elements were metalloids.
And metalloids. Wonderful. Group 4 elements are metalloids. I say, if I remember very well, that for today, let's take group 4 to be non-metals. What is a metalloid? A metalloid is an element whose properties are between the metals and non-metals. This metalloid in class, in a school setting, is a senior 2 student. In senior 1, you are babies. In senior 2, you are transition between. In senior 3, you should be mature. Okay, senior 4, you should be mature. So when you look at a senior 2 and a senior 3, it's a transition, it's an adolescent stage. Now, who has more adolescent properties? Senior 2s have more adolescent properties than senior 1, 3, isn't it? And therefore, because senior 2s have more adolescent properties, I can probably push them to compare them to senior 1s. But I can't compare senior 3 to a senior 1 because a senior 3 is a little bit now what? Mature. So a metalloid has 2 properties. It behaves like a metal, it behaves like a non-metal. But it has more non-metallic what? Property. It's more of a non-metal than a metal. Have you ever heard of a hermaphrodite?
Teacher, why is more of a non-metal?
It has more non-metal properties. Have you heard of a hermaphrodite? A hermaphrodite is a person who is supposed to be having both the male and female reproductive organ, isn't it? But one of the properties in most cases becomes more developed. You have more female characteristics than male characteristics. So what do we call you? We call you generally what? A female. If a child has more male characteristics than a female, that person becomes a female. Both of them cannot be equal. One of them is more than the other. So non-metallic properties are more than metallic what? Properties. So in most cases, it shows behaviors of metals than metals. Are we there? That's why senior 2 quickly that kind of thing. But then they are hardened people. They want to behave like senior 4s. So that kind of thing. I hope I've answered that. Yes, Nabukenya.
Teacher, is the valence
ask your question and we continue.
Is the valence the one that determines the group of a metal or a non-metal?
The valence, the group determines the valence. Valence comes from the group for the periodic table. But there are so many other things that will come outside the periodic table. The group determines valence. One depends on the other because group 1 have valence 1. Group 2 have valence 2, as we saw. Group 3 have valence 3 because they can give out a maximum of 1 to 3 electrons. Group 4 tend instead they accept electrons more than they can give. That's why I call them non-metals. Group 5 have 5 electrons in the outermost energy level. Take, for example, give me a group 5 element, nitrogen. Nitrogen, simple N, has 7 electrons overall. Its electron configuration is 2 to 5. If I draw the diagram, that's the nucleus. Let me draw a bigger diagram. This is the nucleus of nitrogen. It has also 7 protons in it and has 7 neutrons in it. The mass for nitrogen is 14. Outside that, we have 62 electrons. I'm using X to stand for electrons. Followed by a total of 5 electrons you have seen. So why is this one a group 5 element? It's a group 5 element because it has 5 electrons in the outermost energy level. Because it has 5 electrons in the outermost energy level. It's a group 5. Is it a metal or a non-metal? It is a non-metal. What did we agree? Non-metals begin from group 4, group 4, 5, group 6, and group 7. Isn't it? So it is a non-metal. Now, how many electrons can it add to itself? So the outermost energy level can come to 8. We can add how many electrons? 3. 3 electrons. For them, they can gain. They gain. They don't lose. So it can gain 3. So what happens? Group 5, the valence becomes 3. You can add 3 so that they are how many? 8. Group 6, how many do you add? 2 to go to 8. Group 7, you add 1. Group 8, you can't add it because the outermost energy is already full. So that is it. So the group will help us determine the valence. What's the valence? The number of electrons that can be given out or the number of electrons that can be gained. Who gives out? Metals. What are metals? Group 1, group 2, and group 3. Who gains? Non-metals. What are non-metals generally? Group 4, group 5, group 6, group 7. So how many electrons can group 1 give? Only 1 electron which is out. Group 2 will give the 2 that are out. Group 3 can give 3. Group 4 does not easily give, but it what? Gains. That's why I'm calling it a non-metal. And how many can it gain? 4, because it has for carbon 2 to 4. So group 4, how many can it receive? Raise the number to 8. It can receive 4. That's why its valence is 4. Like that down. I'll take more 2 questions. I shall continue to the next lesson. Let me take from Hujurat. Then from there, I'll take from Alicia and we shall continue. So,
Teacher?
Yes, please.
I was asking, is the number of protons the same as the number of neutrons in the nucleus?
No. The number of protons, good question, all related and related to what we are looking at is going to help us.
Same as the number of electrons.
In a periodic table, number of protons are equal to number of electrons. And that atom will say it is neutral. The atom is neutral because protons are positive, electrons are negative. Mathematically, a positive plus a negative, you get a 0 charge. So if I have 2 positives, I added 2 negatives, my final answer is 0, neutral. But we are going to see later on that where P is not equal to E, if P is not equal to E, what has happened? One of the 2 is more than the other. What do you remember now? It could come as a result of either loss or gain. Where P is not equal to E, what does it mean? An electron has either been gained or the electron has been donated or rather what? Lost. So P is not equal to E. Let me look at the first scenario. If protons are greater than electrons, what does it mean? Protons are greater than electrons.
Electrons have been lost.
Electrons have been lost. So they are lost electrons. And therefore, is this a metal or a non-metal?
Non-metal.
Is it a metal? Electrons have been lost. Is it a metal or non-metal?
A metal.
Exactly. This is a metal that has lost. So this could be group 1, group 2, group what? 3. If 1 electron is lost, it's group 1. If 2 electrons are lost, it's a group 2 element. If 3 electrons are lost, it is a what?
Group 3.
Group 3. And such an atom becomes positively charged. It becomes positively charged. Now, what happens if protons are less than electrons? There are more electrons. What has happened? Electrons have been gained. You gain electrons. And therefore, this is a non-what? Metal. Metal becomes negative. And in your chemistry, I hope you have learned about cations and anions.
Yes.
Wonderful. So how many electrons can be gained by group 4? 4.
4 electrons.
Now, I want to use a simple example of carbon. Carbon has electron configuration 2 to 4. Isn't it? So how many electrons can it gain?
4.
4.
Can gain 4. Okay, now let's continue. So you can mute, and we continue.
Yeah.
There is some guy who is talking what I'm not understanding. I'm about to discover that one and I throw him out of the room. So it can gain 4. So if it gains 4, what is the electron configuration now?
2 to 8.
It becomes 2 to 8. Isn't it? Now this formula for carbon becomes C, and we now say C4 minus. Why is it C4 minus? Then I will come back and answer the other question. I want to use simple mathematics now. Carbon has 6 protons and has 6 electrons. If it's neutral, before it gains. Protons are positive, electrons are negative. When you add the two, what you get? You get 0.
0.
Good. Now, when the carbon gains 4 electrons, electrons have changed from 8 to how many?
From 4 to 8.
From 6 to 6 total.
To
From
10.
6 to 10. Isn't it? Now, mathematics, protons remain unchanged. There is no loss of gain of protons. So how many positives are there? We have 6 positives, protons in the nucleus. Plus, how many electrons are there now in total? 10. And we have 10 negative charges. When you add the two, what do we get mathematically? Positive 4 plus negative 10.
Negative 4.
That's why you see 4 minus. So the minus, the number of minuses will tell you the number of electrons that have been gained. And the number of pluses will show the number of electrons that have been lost. It is not true to answer the person who asked the question. It is not true that protons are always equal to neutrons. But there is a slight difference of either 1 or 2. Protons are not the same as neutrons in terms of number. Sometimes they are the same. Sometimes neutrons are excess by 1 neutron. And therefore that can be determined in atomic masses and atomic numbers. So having said that, there was one person whose hand was up and she put it down. Now let us continue. So let us mute and go for the next discussion, and I'll allow you to ask questions. You continue like this, we shall not mute all of you. It becomes easy for us to continue with the lesson. So that is good. Let's move to something else now. The notes are available on your WhatsApp group. I'm trying to be slow because many students have joined. I cannot just rush. And it's a revision, good revision for those, because this is one of the topics that must give you the starting marks in any UNEB final paper: atomic structure and the bonding. Types of bonds. There are quite many, but we have interest in a few. Number 1. Ionic stroke, electro valent. Let us mute. Give you chance. Number 2, there is what we call a covalent.
Covalent.
Now, under covalent, there is something similar that will come in, which is called dative stroke. We call it coordinate. That will come in. Then thereafter, there is something else that will come in, which we refer to as metallic. And there is something that we shall mention briefly, which is called Van der Waals forces. Van der Waals bonds. Let me begin with the Van der Waals bond down here. It is the weakest. In a school setting, it is a relationship between a senior 4 and a senior 1. The relationship between a senior 3 and a senior 1. In almost all schools, people don't want that kind of thing. I've seen it happen. Hey, those senior ones, they have just come. It's a relationship between, for example, one school to another nearby school. Very weak force. In some school, there's what you call what? How do they call it? Status. Isn't it? Hey, they don't allow senior fours to mix with senior ones. So what relationship is between the senior one, other than being a friend from the same school or other than being a relative? I mean, you see very little connection between the senior one and senior two. So this is between the different molecules. For example, if I have carbon dioxide and the carbon dioxide, this carbon dioxide is stable, this one is stable. There is a small link between this one and that one. That is it. Metallic. You have seen from the word metallic is a type of one that is exhibited in metals alone. Metals alone, each metal alone, and this one will come in more or less as a result of what? Sharing certain electrons. Covalent bond is a bond that will come in as a result of sharing. And what do we share? We shall share electrons. But the rule is these electrons, everybody who is participating in the body contributes. Every atom contributes. Every element contributes. You contribute, I contribute, you contribute, you contribute, you put together and what? Share. Isn't it? Biology. What is it? The symbiotic what? Relationship. You contribute, I contribute, we share. So maybe your combined power is you can buy 2 Sumbis, you bring the 2 Sumbis. For me, I can afford one, I bring one. He can afford one, we bring one. So how many Sumbis are these now? 4 Sumbis to be shared. We shall share them. Everybody contributes and you share. We can be the same or we can be different. These atoms can be the same, similar, but they can be different. For example, hydrogen and hydrogen to form hydrogen gas. These are same atoms. But it can be between you and you. You are not of the same blood, though you are all sharing electrons, so it could be H and chlorine. These are 2 different atoms. Are we there? And therefore, this one is going to take place in non-metals. So non-metals form bonds by sharing, contributing, and sharing what? Electrons. So these ones are guys alone. If you have ever seen around, if you have seen, you'll notice that these 2 characters outside the classroom, they are together. Until time for going home, and they separate. That kind of thing. Similar atoms, different atoms. Our home is different from the 2. And what do we share? Electrons. You contribute and share electrons. So this is through non-metals. And it's going to depend on the valence. We shall see. This one, Ionic, oh my God. I don't know what I should say. Now, if I don't know what I should say, what should you say about ionic bonds?
Metal and non-metal.
And non-metals.
Metals and non-metals.
These things, you know them and they happen and they are there in any setting. So do you see a scenario of a metal and a non-metal? And therefore, what did we agree? Metals do what?
Metals lose.
Lose, donate.
Donate.
Metals
And
accept, receive.
Gain.
Exactly.
They
Mute
gain.
now. Can you mute? Namuli, mute. Past is mute. Gain. So this is between metals and non-metals. One gives and the other takes. This is the biblical and in the Quran. Who are supposed to provide? Metals, men. Who are supposed to be provided for? Non-metals, females. So this one has a religious background. It has a biological background. I don't go very far from my class. So how many can you give if you're a metal? What I have in the outermost energy level. How many can you receive? What I need in the outermost energy level. To raise the number to 8. To greet me. So what is my combining power? I must receive how many? 4 chapatis. So if you have one, you have to look for others and combine until you raise 4 what? Chapatis. If you want to house me, I am hungry. You don't give me what I cannot get satisfied. I need 4 chapatis. And therefore, to buy 4 chapatis and hand over this non-metal. If each one can contribute to, we need 2 people to contribute 4 chapatis for this person. If each one can only buy 1, how many students will I need? 4 guys. Buy chapatis for break. If you can afford 4, what do? Only 1 person buys the 4 chapatis. The deal is over. I am satisfied. I come for my lessons. Types of bonds. Objective number 2 has been achieved. Hey, I'm on mute. Hey, your hand is up. Okay, there are 2 hands up. So I'll begin with.
Teacher, could you explain the first type of bonds? Could you explain?
The first type of attraction, which is called by the Waals force, is the weakest force that exists between different molecules of gases. Senior 1 chemistry. Gases can occupy any volume, can move from one point to another. Why? There are smaller forces of attraction that hold them together, and that force is called van der Waals. Here there is no sharing of electrons between molecules. It's a force between a molecule and a molecule. The force between this classroom and this classroom. Right? So what happens during the lesson? Do you all attend lessons? All of you there, we are attending lessons as now? No, each stream. So we say van der Waals force. Throughout the whole day, you are in your stream. Little relationship with another stream until after lessons. Then you disorganize that bonding, you go in for another time. So I don't want so many technical details. I shouldn't disturb you so much. What do I want you to know? I want you to know ionic. I want you to know covalent. And I want you to know what? Metalloid. I'll mention something small about native and van der Waals forces. Shouldn't take a lot of our time. Yes, please. Razan.
Teacher, it's Elaine. Where is teacher? Teacher, it's Elaine. I wanted to ask about why is it that only electrons are the ones given away, not protons?
Hey, why is it only? Protons are located inside the nucleus. They are heavy. They don't move. It is electrons that are found in energy levels. And not all electrons get involved. Only electrons in the outermost energy level can easily be accessed. Protons never move. The nucleus is never. If you involve the nucleus, you'll discover in senior 4 physics that something that we call radioactivity. If you involve protons, you involve the nucleus, it becomes radioactivity, not a simple chemical reaction. So simple chemical reactions involve what? Electrons only. So what is buying of items? Buying of items, we're not going to accept trade, barter trade. It is money. You use only money, not anything else. There are so many other resources you have, but you don't use them in buying tomatoes in the village. I mean, in the market. It is only money that's being used, and not every money is used. Only money in the outermost energy level. Only money in the outside pocket. So imagine you are putting on a nice hijab and you have veiled and you have money in the bra. It is your money. Don't laugh. It is your money, but can you use to buy break? Can you? It is not possible, but it is money. So which money will you use? The money which is in the pocket, not the money which is kept very far, where you cannot access, but all is money. So you not use your necklace, you not use your what? Your ring, you not use your veil to buy, because nobody's going to buy the veil, buy the ring. Market, tomatoes, it's money. So we only use electrons, Razan, followed by
Teacher, may you
Gujarat.
please
Yes.
give me an teacher? May
Yes,
you
please.
please give me an example of covalent bonding? Because I haven't understood. On sharing
When it comes-
electrons, do they
we shall
like an
now,
electron?
to cut you short, that one we are going to look at it. We are going to look at one by one in detail, and you will be with it. I just wanted you to get a little bit of information that this one involves sharing electrons among non-metals. Briefly, transfer of electrons. Briefly, but we are going to look at one at a time, one at a time. So please stay put. Don't lose hope. It is coming. Then Gujarat, lastly, then we shall continue with the lesson.
Teacher, I was confused if covalent bonding is between non-metals and metals, but you've explained.
Wonderful. Thank you so much. It's good you have picked. Continue picking. Don't give up. So you can now put your hands down. Yes, I have another person. Yes, please. That one I'll explain at the right time also when it comes to metallic what? Bonding. I don't want to cross the bridge before I reach there. I'll end with the Naiga Nakato. Finally.
Short about an example of argon.
Argon. Argon is a group 8. Group 8. Group 8 have the outermost energy level fully loaded with electrons. So for them, they don't give, they don't what? Receive. That's why we call them, you know, some that is called inert. Inert. Noble.
No.
Anything that is inert does not react. Escurudofi. What does it mean? You totally don't do anything completely. You are just there like that. So group 8 are like dead bodies. If it involves eating, it doesn't eat. Involving talking, it doesn't talk. Crying, it doesn't cry. It doesn't react because for them, they're in their own world. It's just like babies, the neonates, in their own world. Whatever is happening is not their concern. They don't react because their outermost energy level is full. Therefore, they can neither give, nor can they gain, neither can they share. Are we there? Loners, those terms you use them. So when others are hovering around for them, they don't. So lastly, to be fair, let me ask Agatha to give me, raise her concern and we shall push on.
Teacher, how are the group 8 elements called?
Noble, inert, rare, group O. Noble, inert, rare, group 0. No chemical reaction. And all of them are gases found in the stratosphere or atmosphere, something like that, and so on. In a fact, I don't want to read that one for agriculture students. Now, there is what we call dative. Dative, you come and share what you have not contributed. Texiology. Dative. When others are sharing that, you jump in and also participate in eating, but you have not contributed. You're a parasite. So dative is parasitism. Doesn't it happen sometimes? Oh, yes. It's different from housing. It's different from housing. Housing, I buy and I give you. You take. But when you find me holding, the two of us have bought our sumbis and we are eating. From now, you just come and jump and begin to share. We have not invited you. You just come and begin to eat. And don't even eat more than us, the buyers. So what are you doing? You are sharing where you have not contributed. So here, not all atoms do what? Contribute, but sharing takes place. So with that preamble, I am happy and I am blessed. Without your permission now, allow me look at one type of bond. Those who are raising issues, actually, they were saying, teacher, you are slow. Let's push on, because they wanted to look at the different types. I pick out one, ionic. We say it is electrovalent. Reminder, what did we say? That this one is formed between the metals, wonderful, and non-metals. Anybody should have captured that. And I gave you. Oh, what did we say? Hey, now what are metals? You are terming me. The way the students term us in school, and we remain there. Like the girls of this institution, the great girls of this institution talk about uve. What is uve? Now you see, most of the teachers cannot understand what uve is. For me, I know. So what are metals? Remind me, metals are group 1, group 2, and group 3. 1 electron, 2 electrons, 3 electrons in the atomos energy level. What are our non-metals? Our non-metals are this group 4, group 5, group 6, and group 7. 8 are out. Now, remind me very quickly. Why are they called group 1, group 2, group 3? Group 1 because of 1 electron in the outer energy level. Group 2, 2 electrons in the outer energy level. Group 3, 3 electrons in the outer energy level. Group 4, 4 electrons. Group 5, 5 electrons. Group 6, 6 electrons. Group 7, 7 electrons in the outermost energy. Examples, I think, can pick them from the periodic table. If so, I think here we have lithium, we have sodium, and we have potassium. Here we have beryllium, we have magnesium, we have calcium. And the best example we shall use here will be what? Aluminium, other than boron. But even if it's boron, you can use it. Group 4, the best example shall be using this carbon only. Carbon. Others shall not never use them. So shall limit ourselves to carbon. What about group 5? Group 5 can be nitrogen and phosphorus. And the phosphorus down here. So what are the group 7? There is fluorine, oxygen. There is chlorine, and there is bromine down here. We shall use, particularly this one we shall use so much. So the one you see in a circle is the one that we, in most cases we use.
What is group 6?
That's group 7. You have written it on group 6. Oxygen and sulfur.
Oxygen.
So no, that's group 5.
No,
Teacher,
that's group 7.
No. So this is group what?
Oxygen.
Group 6.
That's
Oxygen
and
sulfur.
This
That's
is sulfur.
sulfur.
So this one is
phosphorus.
Wonderful. So what are group 7? Fluorine.
And chlorine.
So in most cases, we shall use what?
Chlorine.
In most cases, we shall use what? Oxygen. We may employ nitrogen. We may employ carbon. Here we can use boron or aluminium. But commonly what? Aluminium. Here we can use any of them. Here we can use magnesium. So this is what it means between the metals and non-metals. Remind me the valency. What's the valency of group 1? 1. Valence of group 2? 2. Valence of group 3? 3. Valence of group 4? 4. Valence of group 5?
Three.
Two. Valence of group 1. I mean group 10.
One.
Valence of group 8.
Zero.
No chemical reaction.
0.
Exactly, you are coming late.
0.
Fine. Finally, you are there.
Excuse me,
Hindu.
teacher.
Hindu, what is your problem?
Your letters are so small, we can't see.
The letters are so small. But you have
Yes,
been told
teacher, they're very small.
Anyway, because of the limited space, I'm just recapping what you already have. Right? Yes, that was Hindu. So I'm just bringing this because I'm trying to drive you towards bond formation. What happens to metals? We say metals do what? Lose. They donate. What happens to non-metals? Non-metals do what? Accept. Or they gain. Where there is losing, what do we form? We form cations with the positive charges. Where there is gaining, what do we form? Anions. Ions, cations are positive. Anions are negative. What happens when you bring a positive particle, there is a negative particle, what happens when you bring them together?
They attract.
It's like North Pole and South Pole. They'll do what? Attract. So that force that will make them get attracted, that force. So positives and negatives do attract. This attraction in chemistry and physics, what is called an electrostatic what? Force. And it's a very strong force. Electrostatics involves charged particles and particles of opposite charges. Positive versus what? Negative. North pole versus South pole. But you are the people who have been saying, not me. And I know you have been saying, and you have ever said it. But unlike poles, do what? Me, I don't know the word. So let me behave like teacher Pamire. What happens? Class, unlike poles, do what? Attract. Exactly. Unlike poles, do what?
Attract.
Right. Mute. Can you mute?
Attract.
That is okay. So you mute. So unlike poles, attract. So this is unlike positive versus what? Negative. That's why it's between metals and non-metals. Most likely, this is the strongest. Most likely, this is the strongest. And what happens in the schools? There is teaching and counseling. So what happens in the schools? We don't allow interactions to end up forming positive ions and the negative ions in the school. Pairing. Not allowed. Right? And this is a stronger force between a metal and a non-metal. Oh, you are joking. And in the right time, metallic bonding will take place at the right time when you're about 30, 40 years, you have finished university. So you get married now. So electrostatic force between husband and wife. And remember the process they go through, it involves donating, involves introduction into that kind of thing they receive. You end up there now. We accept, we have declared, you go. At the right time, those things can happen. You can announce. It's an electrostatic force between a metal and a non-metal. The lady have to take the present. The lady has to accept them. They end up forming positive and a negative. They attract. That attraction is a bond. Marriage bond, a love bond, which is called electrostatic. What remains is illustration. We are going to illustrate. Have you seen metals and non-metals? Your values, how many can you give How many can you receive? Let's venture into that. So I want us to look at one simple example. I want us to look at, let's begin with 1 versus 1 first. 1 versus 1. I can give 1, you can accept 1. Before you ask for 5 sodas from me. So as we go on, things will become a little bit complex. We begin with 1 versus 1. So allow me to raise the board, then I'll allow you again to ask questions. Master routine on the chalkboard this time. Please don't blink. You might miss. And with me, when you miss, being in class, you'll have missed. Master routine, baby. I want to look at the simplest metal. Let me look at the simplest metal being, say, sodium. I can even begin with the lithium. Because what is the atomic number of lithium? Position of lithium.
3.
Position number 3 in the periodic what? Table. So is in position number 3 in the periodic table. What is its electronic configuration?
2 to 1.
2 to 1.
Whichever version you are
2
using.
to 1.
2 to 1. Which group?
Group 1.
Which group?
1.
Group 1.
Group 1.
1.
Good. Okay, you can mute. Now mute. Group 1, because of 1 electron, the outermost energy level. So, what is its valence? Its valence is 1 because you can afford to give out the 1 electron. So, what is the electronic structure diagram? Here we shall use diagrams. So, what's the diagram? This is the nucleus. I don't have interest in what is the nucleus. I am getting interested in the diagram. I'm going to use different versions, keys. So if this is X and this is X, those are the 2 electrons in the innermost energy level. Now, there is this next energy level, that's why it's a period 2 element. And this is the electron. The 1 electron, the one you can afford to lose. Now you're saying, please, I wanted to come next to trophy, mute. I want to come close to, so when lithium looks around, being a metal, it sees a non-metal called chlorine. You have eyes there, you look around to see chlorine. I want to donate to chlorine. So, what's the atomic number for chlorine? The symbol Cl, it is 17. Mute. What is the electronic configuration? It is 2.8.7. Group 7. Hey, I've drawn 3 instead of 2. Some correction here, I've drawn 3 energy levels, there are only 2. And that meant something else. Right. 7. Electronic structure. This is the nucleus for chlorine. The first energy level has how many electrons? 2 electrons. Allow me use E. Represent that these electrons are different from these ones. The next energy level has how many? Has 8. 1, 2, 3, 4, 5, 6, 7, and 8. And the last energy level has 7 electrons. We remain muted. Let us remain muted. And therefore, if there are 7, these are 1, 2, 3, 4. Pairing begins to take place. So, sorry. I'm not supposed to be using X. I'm supposed to be using what? E. So this is now 1, 2, 3, 4, maybe 5, 6, and 7. Have you noticed that there is only one electron outside which is not paired? So when you look at this one, these are 2, this is 1. These are 2, followed by 8, followed by 7. Like we know, like we say, what was the combining power of sodium of lithium? Group 1. The valence is 1. The combining power of group 7, 1. So this is 1 to 1. I can afford to give out 1. You are ready to receive 1, and you'll be comfortable. So what do we do? I am going to draw an arrow stretching from here, going to that point. Unfortunately, in your notes that are on the web, that are on your WhatsApp group, I miss drawing the arrows. So when you download the notes, draw the arrows. And we shall write on this arrow, electron what? Transfer. The electron is moving. I am transferring here. Stand up, stand up, stand up. Go and sit here. Can you come? Can you sit here? I'm giving you a new position. So the electron is shifting from here to there. So what is the product? The product is, we shall have lithium instead with the 2 to 1 electron now has only what? 2. Because the one has gotten what? Lost. What did we say? The number of charges will show the number of electrons lost or gained. It has lost 1 electron, isn't it? So it gets 1 positive charge. I want to draw its structure here. I'll have the nucleus for lithium. And therefore, these are the 2 electrons that are left. The other one is lost. And if the electron is not there, we don't draw the energy what? Level. So the electron is lost. But I will see it has a positive charge. You can see these are the 2 electrons only. Because this one got transferred. Now, we are having electron configuration 2. This is not helium. To show that it's not helium, we are putting a charge so that it has lost 1 electron. And so what do? We put this diagram in brackets. And I put a positive charge there. Let's come to this one. This is the nucleus. How many electrons at that energy level? There are 2. This is E, and this is E. Next energy level, 8 electrons. You have seen these 2, E. There are these 2, there are these 2, and there are these 2. Outside them. Give the original ones first. Show me the E's first. The 7 E's. Original. There is this E. There is this E and E. There is this E and E. There is this E and E. But now X has also what? Come in. And therefore this is now X. X has now come in. And therefore what happens? What was originally a chlorine with EC 2 to 8 to 7 now has the ECO 2 to 8, 2 to 8 to 8. It's abnormal. 1 negative charge extra. And therefore, what do? Negative. Sign. It has gained 1 electron. So what do we do? Also in the brackets. What do? We put the negative charge. Now, to show that these are charged particles, in most cases, we introduce a big dot in between them. That big dot is what is holding them together. It signifies an electrostatic force. This dot. Don't make this be very far from one another. How do I attract the negatively charged particle if I'm here and the particle is as far as, I don't know how I can just find. It's a square. There must be close to one another.
Chlorine will lose one electron.
So if I remove this one,
Like if you remove
this one here, I bring it back this one.
chlorine will lose.
It would mean that someone is asking, somebody cares to know. Supposing I removed this one and I brought it back. For this one to come back this way, it will do when this chlorine has given it back. So what? It's electron. You return my chapati. Nzilizo rukumi wangu. Give back my phone. And when I give back my phone, are you still my friend? When you return the phone, am I your friend now? No. That's how come. I can go back. But it's not better what? Is the chapati Nigerian day? I will solve it. How do I bring this thing of giving the bomb may not work? In the history of what? Of what? Of peace said and what I don't know. So many years ago. When you were not even there, even some of your mothers and fathers, parents were not there. For me, I was busy reading about that so many years ago. So this is what's going to happen. This is an electrostatic force. So a sodium atom, a lithium atom becomes a lithium ion. A chlorine atom becomes a chloride ion. The ions of opposite charge electrostatically do what? Attract. You can now convert this message into an SL, right? So what will you say? The sodium atom what? Transfers or donates the one electron in the outermost energy level to the outermost energy level of what? Chlorine, isn't it? Yeah. If you know the names of the ions you mentioned, if you don't know, you say ions of opposite charge are formed. These ions attract one another with a strong electrostatic force of attraction. Now, second option. In the second option, I want to repeat this. And I want you to look at the two and choose which one is simple for you. You do it. This is one option. This one already said is. In the second option, somebody says, this is the nucleus. Those are the two electrons. Are we there? And says, what's this bracket? Let me first do it the way it appears there. This is plus. This is a dot. The way it appears here, and therefore this is the second bracket. This is the nucleus with the 2 electrons, with 8 electrons. Please watch this and see what's going to happen here. And these are how many electrons outside now? 8. But out of the 8, one is X followed by the E's. And I'm putting this bracket. This diagram, it is now a diagram. They are no longer diagrams because the two are now one, isn't it? That's why for Christians, they are told that in marriage, 1 plus 1 is equal to 1. It's not 2. Because the two behave as if they are linked together, you can't separate them. Daddy and mommy at home must think and think in a similar way. They behave as if the two heads are one, because what mommy knows, daddy knows. Though they are two people, but in terms of character, in terms of behavior, they behave, must think in a similar way, or else we shall end up contradicting one another.
I find out a black hole is the origin of space.
Hey, mute your microphone. We don't want your stories. Eh? Nantal. Mute your microphone. I'm on mute your microphone. Would you not mute your microphone, or else I'm deleting you from the chat room? You'll ask. Allow me to conclude. You'll ask on this one. I'm going to give you a chance to ask. So what happens? You can choose to remove this bracket. When you remove this charge, you also remove this bracket. Also come and remove the negative charge which is here, and also remove this what? This bracket. So what has happened here? The two ions are in the same bracket. And when they are near one another, these charges do what? The charges do what? Cancel. So here we don't show the charges if they are close. But in between these two diagrams, there must be a dot. And if you check in the notes on your WhatsApp group, that is what is happening. So if this one is simple for you, take it. If the other one is simple for you, take it. Commonly used is this one. And therefore there is this one. I want my students to be exposed to so many ways of doing the same thing. So that at one time, nobody can ask, hey, they have cheated because everybody is writing the same thing. So these are the two versions. You'll come across this one so much in the books that you have been reading. You're coming across this one. The way I wrote electron configuration as 2 to 8 to 7 is a version of writing electron configuration. This is a version. Commonly used is this one. There is also this. So as everybody is using this, the real student comes and uses that. Even if there is aspect that there is a problem. I mean, your format of doing things is different. So I'm getting what I know and what I understand it very well. So this kind of thing. Ionic. Before we continue, Hujurat, your hand has been up. Can you ask your question?
Teacher, I was asking, like, instead of that arrow, can you use the addition sign?
Hey, this one. No, this one.
The other one.
Number one. You note
electron
that this
transfer.
is telling you. The rest of you mute. She asked me.
Yeah, when we are transferring the electron.
Now, the issue is, this arrow is telling that we are moving from here. This is now the final product. This arrow shows that we are moving from here to here. Probably what I would have said, is it possible that we can add here? I don't want to use a positive sign because we're not adding this one to this one. It is telling you that something is taking place. However, even if you leave your addition sign there, I will not quarrel because we're not going to change the meaning. So you can put the addition sign at this point. In this one, you can do without the addition point, but electron transfer is very important. So if it makes you so happy, you put it there because life is short. Do you think that can make you happy within the rules of the game? So not say because I'm happy when I go out and I come back at midnight, it makes me happy that the rules of the game can be allowed to go out and come back at midnight. So this was
my other question is,
yes.
Like this dot, what is it for? The
What?
dot.
This
The
dot. That dot is a symbol to show that is a strong force. In chemistry, this dot signifies an electrostatic force between. It's that force. You may not see it, but you can feel it. Get it? That force that binds you with another person. So we use this to show that electrostatics in chemistry. Opposite particles attract with an electrostatic. So this dot shows that it is an electrostatic force. And so what's an electrostatic force? A force of attraction between two or more particles of opposite charge. So that one I've answered.
Thank you.
Now Sasira followed by Amon. Then we shall continue with another example. Ask.
Teacher.
Ask.
Teacher, why are cations given a positive yet they lose?
There is something you missed. I said they are given a positive because they now have more positive charges than negative charges. They have more positive charges and less negative charges. I want to repeat that, and we say that if protons are equal to electrons, the atom is said to be what? Neutral. It bears zero charge. If protons are not equal to electrons, it becomes charged. And it is either positive or negative. Isn't it? And we agreed, the question was asked by somebody, that if protons are greater than electrons, remember protons are positive, electrons are negative. If protons are greater than electrons, So what will happen? This atom becomes a positive ion. And it's given a name, cation. How does this happen? To have more protons, you should have lost electrons. You should have lost electrons. I want to use an example of this very one, lithium. Lithium, the one that we looked at, it has 3 protons and has 3 electrons. As any atom, this side, before we cross to the other side. So if it has 3 protons and 3 electrons, protons are positively charged. So it has 3 positive charges and it has 3 negative charges. In mathematics, when you add the 2, what do you get? 0. That's why lithium has no charge. Now, when electron loss takes place, what happens? Lithium will remain with its 3 protons, but the electrons have changed to how many? To 2, because one has gotten lost. That need only 2 electrons. So what do we have? We have 2e. But remember, the e's are negative. When we add the 2, what do we get? We shall get one negative charge. That explains why it has a positive if charge lost. Meaning that now protons are more than electrons by 1. And the same thing happens for nanometals that I'm going to go into because time is not on our side. So this is what's going to happen. Yes, Amon? You are free.
Teacher, is it always a must that oxygen, fluorine, and chlorine are supposed to be used, like the second part?
Are supposed to be?
Oxide.
You are mentioning it.
The only one supposed to be used.
Those are the common ones. There can be others, but those are the common ones, easily used that can be understood. I don't want to go to very complicated examples first. I want us to understand the simple ones first. Those ones will come in later. If we have now revised, we have understood, I'll bring the complicated ones later. But those are the common ones. When you're introducing children to food, what do you begin with? Milk only, breast milk only. Then hyena milk follows. If you don't have goat and cow milk.
Mashed potatoes.
Now you go to mashed potatoes, porridge like that. You cannot say, child, then you bring a piece of cassava. Cassava. Big cassava. How? It's not impossible. You give a child a carrot to eat. So you begin with the simple foods, then you mature into complicated ones. Later, having grasped the idea. And lastly, Amina, then I'll come to you. Amina, can you ask and we continue, please? I want to give in another example.
I wanted to ask, since it's the outermost energy level that is involved, is it okay if I draw only the outermost energy level?
That's a second scenario. Let us grasp the idea first. I'm going to come to it. Nice question. But I cannot jump from this to the other. Let us first understand the idea. Then that one is going to come because an instruction that is also given. Wonderful. She's saying, since you are involved in outermost energy levels only, why should we draw others? I will come to it. And it is possible, as the one that is even wanted the most. But let's first of all understand the idea, and we shall come to it. Good. So, yes, your hand was also up. Of course, somebody is asking, metals lose electrons to become stable. Non-metals gain electrons to become stable. That is what we call the Octet Rule. Cation and anion formation takes place in order for elements to acquire stability so that they look like group 8 elements. Once you have given and have accepted, you become stable, I become stable. That differential keeping us together makes us very stable. Period. You look at another person. No, you look at me, and I look at you only because I have given, you have accepted. There are heavier terms I could have used, which is not allowed. So should you want to bond to another person, then that is cheating. Unless you break up with me, then you can get bonded to another atom. And you know, certain things are not allowed. So there is no way you can cheat on lithium if you are formed a bond with lithium. If you don't want lithium, and I am going to want to form with another one, then you must break up with the lithium first, so that you can form with magnesium. So that is it. Right, more questions are coming. Lastly, Munira, answer the last question for now. If you're not ready, we continue. Munira, your hand is up.
Excuse me, teacher.
Excuse me.
I wanted to see how the configuration of elements in group 4 works.
Okay, fine. I have no problem. But it's going to be a heavier example. It's going to be a heavier example. But if that's what you want, there is no problem. For example, here says you want to see how. Let me do it. Maybe our last example. But if I go to that one, there are just a few minutes. Allow me look at the second small example and another, then I'll go to that one. Let us look at magnesium and oxygen. Or maybe let me look at now magnesium and maybe okay, magnesium and oxygen. So what do we form in chemistry? We form magnesium what? Oxide. What have you seen there? The combination is 1 to 1, meaning they have the same valency. So EC for magnesium is 2 to 8 to 2. EC for oxygen is 2 to 6. So who loses? Magnesium. How many electrons? 2. What do we form? Magnesium ion. So what shall we have here? I'm going to end up with magnesium electrostatically bonded to oxygen, which in normal chemistry using one bracket will be written as MgO. But here I have 2 brackets now. I have these 2 brackets, isn't it? So if electrons are lost, how many can be lost to 2? The EC becomes 2 to 8. What did we agree? Magnesium, how many protons are these? 10 positives plus 10 negatives. Hey, this is 12, sorry. 12 positives plus 12 negatives. Isn't it? Here we have 6 positives plus 6 what?
6
negatives. 0, 0. You can see no charges. So what do I have here? I now have 2 to 8. So how many positives? 12 positives
10
plus 10,
10
electrons. So
Teacher,
what do we get as the answer? The answer is -2. So this is equal to?
Teacher, it's 10.
Yeah, it is 10. Is. Protons have remained 12. We have lost 2 electrons. Electrons have remained 10. When I add, what do I get? I get 2 positives, so it is +2. So I get 2 plus. Remember, electrons are negative, protons are positive. So which means this is a 2 plus, showing that it has lost how many electrons? 2 electrons. So what about oxygen? The EC for oxygen now is 2 to what? 2 to 8. It has gained 2 electrons. So it has 6 what? Positives. It now has
it's 8 on the
it has
first
8 positives, yes, and 10 negatives. So when you add what you get? 2 minus. So
2 negative.
-2. Let me draw a diagram and we shall see. I want to remove this now. Quickly draw a diagram because time is not on our side. Magnesium. Two electrons inside, 8 electrons follow, and 2 electrons out. oxygen, nucleus, 2 energy levels only. So what happens? 2 electrons inside, 6 electrons out. So this is E, this is E, this is E, this is E. How many are those? 4. How many are missing? 2. Raise the number to 6. So let me put E here and I put E here. So what happens? Who donates? Magnesium. Are you seeing? I'm going to transfer this electron to that point, and I'll transfer this electron to that point. Electron what? Transfer. What do we obtain? The nucleus of magnesium with now 2 energy levels only. So this is X, and how many that will be left outside? 8. X, X, X and X, X and X. What did we agree? Brackets. 2 plus. Dot. Oxygen now becomes nucleus. How many electrons inside? 2. How many outside? Original ones. E, 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 E. Now X has come in. X has come in. Brackets. Wonderful. 2 minus magnesium oxide. If you want the other format of having 1 bracket, what shall we do? I remove this 2 and this bracket, remove this bracket, and I remove this 2. Magnesium oxide in the same bracket, under the same protection. That is it. So what do you say? The 2 electrons, the outermost energy level of magnesium is transferred to the outermost energy level of oxygen. So what do you form? If you don't know the names of the ions, you just say ions of opposite charge are formed and they electrostatically attract. If you know the names, magnesium forms magnesium ion, oxygen forms an oxide ion, the ions of opposite charge electrostatically attract. That is it. Somebody talk about group 4. Few minutes, I can use that to illustrate. Between magnesium and chlorine this time, before I can answer your question. Now let me look at magnesium and chlorine. I am changing the concept. Symbol for chlorine is Cl. What's the electronic configuration of chlorine? 2 to 8 to 7. How many electrons can be donated by magnesium?
2.
Magnesium can donate what? 2. How many electrons can chlorine accept? 1. 1 from the electronic configuration. Isn't it? I want to use 2,000 shillings, but you can take only 1,000. So what happens? You look for another friend. You bring another one. So I pick 2 people. Each taking 1 electron. Isn't it? So I pick another chlorine, which means I need 2 of them. I need another chlorine here. So what I can do, I can draw 2 diagrams, or I can draw 1, but put a 2. So let me draw 2 diagrams first. This is my magnesium. So this is what I'm going to do. I will draw 1 chlorine here. Then I'll draw another chlorine. I can draw it this way, wherever you want. So let me draw another chlorine here. What's the EC? 2 to 7. These are 4, 5, 6, maybe 7. I can put it up here, I can put it wherever I want. The choice is yours. I can even, for purpose of easy writing, let me put this one here. So this one is also 8 to 7. So what do I do now? I transfer this electron to this position, isn't it? And then if I give this one to the other, so I need 2 people. I can give out 2, but the people who are below me each can take 1, so I need more 2 people. Lukumi lwengendo okugaba na 12. Abagala lukumi balina okubeera bameka 2 of them. So what do I obtain? I will still remain with my magnesium. Iron 2+. Now this one becomes a chlorine, isn't it? Hey, this was oxygen. So if it is chlorine, I'll put E and add another energy level. Let me add another energy level. So what is it? E and E, but there is X. And this one has gained 1 electron, isn't it? So there is 1 negative here. Are we there? So what you do is you draw another one. You draw another diagram of the same and also put what? Minus. And put 1 dot somewhere. So you can push this one slightly up, push this one, so that maybe you have a diagram of this nature with your dot there. Or you can bring this and put it on this side, so that you have Mg with all its work. Therefore, you have the Cl minus here and another Cl now minus here with this dot and with that dot. This one requires more time. You are spending more time drawing. So what is the cheapest? The cheapest is what you do is, instead of drawing this twice, you put a 2 here and remove this one. Are we there? You put a 2, meaning they're going to be 2. Instead of drawing this one 2 times, you draw only what? 1. And then I'm removing this one, and I put a 2 here. Plus, meaning there are 2 of them. Are we there? So I'll only show this one because the other one, which I'm not sure, will also take the other. So what do I obtain as a product? Instead of drawing this one 2 times, I'm going to put my dot, isn't it? And I put a 2 here. Meaning that the combined power is 1, the combined power is needs 2 because each of this can take only 1. So with the practice, it will become relatively cheaper. Finally, the one who talked about, and I want to use this format for group 4, let me use that, look at sodium and carbon. Maybe in our next lesson, I'll review this before we go to something else. What is sodium? Is Na, number 11. Electronic configuration 2 to 8 to 1. Carbon 6. Electronic configuration 2 to 4. You have already seen these things now. How many can you donate? 1. How many do I want? 4. You can donate 1. I want 4. So what happens?
You get many more sodium.
So go and look for your friends of your type. Go and look for friends of your type and reach 4 and come. So it means I'll need 4 of these ones because each can give only what? 1. Now, drawing before this one is possible, it becomes too much. You're supposed to draw 4 of them. So I'm supposed to be having another one 2 to 8 to 1, another one 2 to 8 to 1, another one 2 to 8 to 1. Now you can see, if you enter the lesson at this time, you would understand me. If you have been dozing, have been taking off to go and open the fridge and take juice and come back and you miss the course, you can't now follow. So have you seen? Isn't it? So this one transfers. Because the EC for this one, as for now, the EC for this one is now nucleus, 2 electrons, and how many electrons outside? 4. So this is E, and E. The asker of this question, if that language is there. So what will happen? This 1 electron is transferred. This 1 electron comes here. This 1 electron comes here. This 1 electron comes here. So how many of these are paid? 4 versus 1, combining power. So what does the EC become finally? Sodium becomes plus, but there are 4. Electrostatic. What is carbon C? With which charge? 4 minus. Are we there? So what is my product? My product is 4 of these ones, nucleus with 8 electrons, X, 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 and X. But each one of them has 1 positive because you're losing 1 electron. But there are 4 of them, bonded to a carbide ion, nucleus, energy level. So what do I have? I have E and E. So what do I have here? XE. What do I have here? XE. Here is XE, and here is also XE. And what is it? 4 minus. Are we there? If you don't want to now say this big bracket, when you put a 4 outside both brackets, it controls all of it, which is very wrong. So what do? I put a 4 here. Then I say, what is this? This is X, 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 dot. Eh? So there is this one alone now. So this is E, E, X, E, X, E, X, E, and X, E, and I put that in bracket. So these other ones, as you continue understanding more, they become a little bit complex and so on and so forth. So for those of you who have phones, look at this. For those of you who don't have phones and are live in class, you cross this way. For those of you. You must read the Zoom lesson to access, but I think I sent the file. You downloaded it. Did you download it?
Yes.
So you cross. Those of you who don't have phones, as for now, cross this way. Quickly, I want to end. Masks on. You're live in the class. Be faster. It's past time. All right. Are you capable of seeing your screens?
Yes.
On your phone. Atomic structure. Atomic structure. An atom is made of protons and neutrons and electrons, the 3 particles seen. Continue down. You have seen that a proton has a charge of +1, a neutron has no charge, an electron has a charge of -1. That is the structure of the atom. When you talk about first energy level, second, third, you can see them. Next, you are seeing that protons inside the nucleus have a unit of 1 mass and have a charge of +1. Illustration. So allow me to move very fast with the minimum delay. What we have been looking at. That is the electronic configurations, structures, and so on. Download the table and fill it to determine the group and the period of an element. Group 1, 2, 3 are metals, 5, 6, 7 non-metals, and we shall add group 4 metalloids. But the metalloids have more of non-metallic characters than metallic characters. As you continue from my explanation, the periodic table will help you know group 1, group 2, group 3, and group 4, group 5, 6, 7, and therefore the combining power. And if you look at the table where you wrote electronic structures, you can also write the electronic configurations. But the idea is simple, that the group of an element is determined by the number of electrons in the outermost energy level. We are noticing that quickly, to form ions, you either lose or you gain. Therefore, we have positive ions and negative ions. Positive ions, electron loss. Negative ions, electron gain, depending on the group. Maximum loss can be 3, maximum gain can be 4. Group 4, gain 4. Group 6, group 5, gain 3. Group 6, gain 2. Group 7, gain 1. Group 8, not gain. Group 1, lose 1. Group 2, lose 2. Group 3, lose 3. Today's topic was structure and bonding. Definition of a bond, you can get it. Types of bonds, as we discussed, they are there. So now, the first electrovalent ionic bonding. What did we agree in electrovalent bonding? We agreed type of bond that occurs as a result of complete transfer of electrons in the outermost energy level from one atom to another. It occurs between metals and nonmetals. So the metal atom transfers electrons to a nonmetal. Ions of opposite charge are formed depending on the valence they electrostatically attract. So that is formation of sodium chloride. The arrows are missing for electron transfer, but when you study the diagram, you can follow it. Arrow, I've used the second format of putting them in one bracket, and you can see there is another dot somewhere in the middle, which looks as if it's displaced. That one is an electrostatic force. So you read it through so that you can ask questions. Now, calcium chloride, though we have been using magnesium chloride, is seen here that you have seen one calcium can donate 2 electrons. Each chlorine can gain 1 electron. So what do? We need 2 chlorines. I've used the summarized format. And therefore, you can see this is a calcium ion dot 2, then a chloride ion in electrostatics. So it's formation of sodium oxide, 2 sodiums, since each oxygen can receive 2 electrons. So we need 2 of them. And the product is there. There is that dot. But you have seen the 2 before the bracket so that it only controls sodium. So when you put the 2 outside the bracket, it controls everything which is in the brackets. I'll ask you to do part D for me for calcium oxide, which I think I used magnesium oxide here, and so on, so that we can continue. So alone, read about the properties of ionic and covalent compounds. I'll quickly go through those ones, followed by the next bond, which is covalency. As somebody asked, how do we know that covalence has taken place? That is our next discussion. As for now, we shall break off so that we get ready for the next lesson, which is at 11:30.
Bye, teacher.
Thank you,
Bye.
teacher.
Thank you, teacher, for teaching us. May God bless you abundantly. Bye.
Bye.
Bye, teacher. Guys, keep safe.
Bye, bye.
Keep safe.